Ohayo gozaimasu. Watashi wa Stefania desu. I know I'm sitting between you and a coffee break and a lunch break, and you've been hearing a lot of different talks. So before we get started, I'm going to make you go up and stretch a little bit because there's a lot of science that show that that's going to allow you to focus better on my talk, and also that it's good for you after sitting for so long. So why don't we all get up in the overflow room as well? I hope you can do that. And then just stretch, take a deep breath in. Wonderful, thank you. Thank you for playing with me. Now we're gonna go back. Yeah, this is gonna be a very interactive, playful talk. So I just wanted to get you in that mood. We're gonna talk about what learning is in the era of AI. And I want you to raise your hand if you learned something new in this week, like a new framework, a new API, a new pattern, how to cook something new, I don't know. Okay. Keep your hand up if you can't remember the last week when you didn't learn something new. Okay. There's some active learners. This is our superpowers as developers, as researchers, as humans. Learning new things, our ability to learn, unlearn, and relearn is what makes us irreplaceable, all right? And this learning curve, I'm sure you've noticed, in the past year has gotten exponential. Not only for AIs, also for us, humans. There's actually a recent study that shows that 74% of tech professionals mentioned that they need to update their skills annually just to keep staying on top of their work and remaining competitive. So the question that arises with this is, how do we prepare the next generation if we learn at this pace, right? And the continuous learning and continuous adaptation is the new norm. Well, I'm going to leave you with this number for a little bit. 46%. This is the drop in entry-level tech hiring in UK. This was just published last month by the Institute of Student Employment. So not only that the exponential curve of learning is happening in technology, in computer science, but also the entry-level jobs are going away. So there's a paradox here, and this paradox is not new, but it's amplified today. We need experience to get a job. At the same time, we need a job to get that experience, right? So if AI is going to automate these entry-level tasks, how are the new people supposed to learn these skills? Where does the mentorship and apprenticeship coming from? So traditionally, we had a pipeline. We would have junior devs that come in and learn the ropes, then mid-level people that mentor them and can understand more of the trade-offs in the code, and then senior people who can oversee the architecture, the process, who really understand the why behind many of the technical choices and decisions. Now, if AI is replacing the junior entry level, where does this expertise coming from? How do we get, what's the ladder to get this expertise? Moreover, we know that open source communities were a great place for mentorship, for apprenticeship, for junior developers to get their hands on. But right now, the maintainers of open source communities are being completely overwhelmed, right? They get a lot of pull requests. Some are done with AI, some are done by people, some are done in combination. But a recent study from last month from Meter showed that these maintainers of large open source projects are being overwhelmed, and they're actually not more productive with AI right now. So there's a shift in computer science practice and learning. We went from hello world, right, learning by doing and learning how to write the code and the syntax by hand, to the review era. An era of where AI writes the boilerplate code and the code, and we sort of need to learn how to read it, to review it, to approve it. So this actually shifts the way we think about learning in computer science. So instead of starting with the skill of syntactically writing the code and knowing how to do so, learning how to do so, the scarce skills now are more computational thinking. How do we do problem decomposition? Critical verification. How do I know to test what works and what doesn't and why? Logic interrogation. Why does it work? How can I make it better? What are the trade-offs? And this question right here and this approach is right now at the top front of priorities in all major computer science departments. All major universities created task force to revamp their curriculum and figure out how do they train the new generation of developers. So we know what AI does well versus what requires understanding. We know that coding assistants right now are pretty good at giving code suggestions, right? They're pretty good at writing like boilerplate code for common patterns. They're good at writing tests, maybe generating first drafts for documentation. But they still require human judgment when it comes to formal verification, to architecture decision, to important trade-offs in optimization. And they definitely struggle when the code source is extensive. Or they also struggle if, I don't know if you've tried recently to use Claude Code for Haskell, any of you? If it's a low resource language, right? Like if it hasn't seen a lot of data. Or to do license compliance. We care about open source, that's why we're here. So just telling people just use AI isn't enough. And the main reason for that is this. Can any of you guess what that curve means? It's this term of jagged intelligence. Andrej Karpathy, right, who kind of started this whole vibe coding movement, also talked about jagged intelligence. And this is very hard for humans in general to wrap their heads around, but in particular for newcomers, for juniors. It's very hard when you don't know what you are supposed to know, or you don't know the basics, to kind of assess like this new system that is very powerful at writing new math proofs, and expect that it might not be able to count the number of R's in strawberry. So this jagged intelligence, like the fact that these models are so unpredictable, like what they're very good at and what they're good at, and that we need to sort of develop a sense for that, is hard. It's hard for everyone, and in particular for beginners. So if there's one thing that I want you to take away from this talk, is that we are currently seeing a loss of epistemic agency. This matters. This matters for open source communities and for contributors to open source communities. It matters for future of learning in computer science and beyond. Because we want a generation of people that know why something works. Not only that it works or that they're trying to get it done. Understanding the why behind is crucial. So this is not inevitable. This is a design choice. We can choose to design AI systems that don't give answers, and in turn, they actually ask us questions to lead us to the answers and help us learn in the process how to reason about the problem. And I'm going to show you how I've done that and why I'm interested in taking that approach to learning. So why am I so interested in learning? This is me. I think I was like, I don't know, 5, in Romania, in a very small village in Transylvania. We still had communist regime at the time, hence the dolls and the setup. And I grew up in a very small village with limited access. Like, I built my first computer. And from there, from this small village in Transylvania, first generation to go to college, I was able, through education and through studying and working very hard, to get to MIT, to start an NGO for teaching STEAM to kids around the world, to learn hardware and be able to build and fix anything in my house. All of this was because education, and because I was able to learn. I had good mentors, good teachers, and also access to high-quality resources. So I wanted to share that back, and that's why I started Hackademia, which is an NGO where people learn by doing and playing. And I ran this all around the world. There were hackathons that happened in Bucharest, back in Romania, in South America, in Africa, literally all over the world. Because I think it's also that learning happens in community. It doesn't happen in isolation. We learn much faster and much better when we learn together. And another project that embodies this was AfriMakers. This was crowdfunded with Indiegogo. And here, it was also like hands-on learning for CS and hardware, but focused on social impact. So in each of these countries, 10 African countries, we were focusing on big social problems in the local communities, access to electricity, access to clean water, and then empowering teams and partners on the ground to build these solutions. So this was done with the network of fabrication labs called AfriLabs. So each country has one of these centers. All of the projects are open source. And the best part was this apprenticeship model that I was telling you about really works. So I was the only foreigner that went in Egypt. This was the first team trained in Egypt. Then some of the people that were trained to program microcontrollers, build solutions, like we were monitoring air pollution in Egypt because it's a really big problem by making these giant balloons change color if the air is too polluted, because the government was prohibiting this at the time to have that data be public. And then these people who learn how to do this, some of them got a scholarship, a fellowship, to go and train the next team in Kenya. And the people from Kenya got the scholarship to go and train the people in Rwanda. The people from Rwanda went and trained the people in Ghana, and so on and so forth. This is the last Maker Faire that we did. This was at the Ghana University. There were over 400 people that were learning how to program for the first time using microcontroller servers. And then they would go and teach kids in schools as well. So training of trainers is highly impactful. And this apprenticeship model really works. And it's sticky. And I'll show you how sticky it is. Because years later, this is probably, I don't know, 6 years after that program, one of the students tagged me on LinkedIn, and this is just one example, saying that experience led him to a career in computer science, and that he ended up collaborating and working with the people he met at these hackathons and these events. So we know that the education needs a wake-up call. We know there are lots of issues, and we know that access to high-quality teaching and high-quality educational resources is not evenly distributed. At the same time, there are opportunities with this new technology. In particular, Generation Alpha and Generation Z are the fastest adopters of generative AI technology. They use it for their homework, they use it for tutoring, they use it for financial education, all different aspects of their life. So I really wanted to explore how could we use AI for young people to encourage Socratic learning. Not give them the answers, ask them the questions. And I was motivated to start with Scratch because it's the largest platform for kids coding online. I was also part of the Scratch team at MIT during my master's. So I modified Scratch to build the first platform for AI education. It's free, it's open source, called Cognimates. And this platform was launched in 2016. So it's a while back. And I'll show you a quick video of how kids use it.
So we were programming robots.
You could play rock, paper, scissors.
Okay. You did rock, paper, scissors into the camera, and on shoot you did one of the motions, and the camera did one of the motions, and it's like rock, paper, scissors, shoot. The computer gets like better as you play the game, because like us, we might not know everything at first, but if we keep trying, we get better.
Everyone has heard about like machine-based learning or artificial intelligence, and there was a sort of no questions asked for a lot of the more tech-savvy parents. It was like, go for it.
Technology is going to be a huge part of their lives, much more so than my life. If it's scary for some people, this AI technology, I totally get it. But as a parent and as a teacher, I thought it was really important because these are skills that 21st century kids need to have.
When my dad was young, he bought a car and took it apart to see how it worked. So you teach people that young how these things that grown-ups mostly program, how it works.
So kids want to take the car apart. They want to take the black box apart. They want to train their own models. They want to understand how it works. They want to be in the driver's seat. And when we enable that to happen, when we allow them to train their own models, when we allow them to understand why a model performs well, how to change the training data set in order to make the model perform better, we actually see that they become skeptical of AI intelligence. So we did a longitudinal study in after-school programs, 6 weeks. And we asked kids in the beginning, how intelligent you think AI is? Do you think it's smarter than you? Then we allowed them to train their own AIs, program the AIs, and we asked the same question again at the end. And we saw the difference. It really demystified this intelligence of AI. Where does it come from? Why does it matter that we understand how it works and how we can change it? And of course, this was back in launch in 2016, research until 2018. The most recent iteration is that I actually added a copilot as well, which works in all the major languages. And I can show you a very quick demo. So it's available online, and then if I go here and say hi, it's going to ask me a question. What do I want to learn? Maybe I want to make a Pac-Man game. Oh, thank you. That would be entertainment just for one, not the best demo. And let me try to make it bigger, too. So I told it, hi. It's asking me what I want to do. I'm going to say Pac-Man game, maybe. I can also talk to it. I'm not going to do it now with the mic and everything. And then it's going to ask me more questions about the program, like how am I thinking about my game? It's not going to go and start generating the Pac-Man game for me. And maybe I'm like starting to build a game, or maybe it allows you to import games that kids build online on Scratch and open them. And let's say I build here like what I want it to be like part of my, oh, it's very hard to do this on 2 screens. It can explain the code as well if I can get to the right screen. Whoop. You have to believe me that it explains the code. I'm going to stop here with the demo. But I can take screenshots of the code, and in real time, it's going to give me explanation, generate artifacts for me. And then if I switch the language, it easily switches between Romanian, Japanese, English, and I can talk to it as well if I don't want to type. And I evaluated this new platform with kids from 15 different countries in their native language, and found, according to their parents, that they spent double the amount of time programming because they had this infinitely patient Socratic AI tutor. And that it helped them generate ideas for their programs, it helped them debug, it gave them affirmations, but it didn't do the work for them. And I'm going to give you another example in math. In math, we've seen the biggest learning loss during the pandemic. So it's a really big problem. And that's also math education is also one of the main reasons we're losing people in STEM and we're losing women in STEM early on. So together with my collaborator, Nancy Otero, we built this benchmark of 55 most common math misconceptions in algebra. And then we used, this is available, we made it public, it's published. And then we used this misconception benchmark to actually create a math tutor that it's not telling the students like this is the right answer or the wrong answer, because that's not helpful for learning. It helps them debug their thinking. If you get the wrong answer, why is that? Maybe you don't know the order of operations yet, right? Or maybe you don't understand negative numbers or fractions. And maybe you want to practice that concept until you get it right. This is much more motivating than telling you got this score, or this is right, or this is wrong. And it's helpful for teachers, too, to know which concepts do they need to go over more and which concepts the kids already have. So and it creates reports for the students, the parents, the teachers. And I evaluated this system against open source models. And I wanted to emphasize on evaluation that it's not just the accuracy of predictions of the misconception, but it's also all these other dimensions. Is the system Socratic? Is it age appropriate? Is it coherent? Is it concise? And this is actually from last weekend. I tested it with students here in schools in Tokyo. And they loved it. And it was so, for them, empowering to have a tutor that allows them to do math on paper. It doesn't force them to go to a device. And it keeps asking them questions. And if they get something wrong, it gives them additional exercises. And of course, they had fun, and they tried to break it. I told them, you have to make an impossible math and see if you can trick the AI. And they loved doing that, right? So I had one of the students were like, let's put some infinity in there. So from these examples, and there's many more, I wanted to show you how children learn with AI. And when we create the right environments, we see that they can discover core concepts, both of how AI works, but also of other domains. It fosters critical reflection for them if these tools are Socratic. And it allows them to learn in creative ways, because that's more engaging. When you build a game, when you can trick the AI and then fix it, it needs to be fun as well. So this is not just for children. It's for all of us, right? And as AI gets smarter, this question remains. How do we ensure our shared knowledge remains human? And if you are in this room, if you are at this conference, you care about shared knowledge, right? So I think there are some parallels that we can draw. Like, what does Socratic AI means for the OSS open source pipeline? How do we use it for mentoring newcomers? How can we leverage maybe some tools to support maintainers, like ask the contributors, like explain your logic? Like, are you sure this is the right way? Does it pass this test? But also to lower the barriers for everyone. Like, if you're onboarding into a new code base that is very complex, how does it break it down? How does it explain it, right? So we can focus our energy on the questions and the problems that matter. And I think the open source imperative, you heard a little bit about this morning, right, is crucial. Because we don't need only open models, open weights. We actually need the data. The data is very important. And what kind of data? We need misconception data, like in the math example. We need learning traces. We need data about the process, not only the final product. If we want to build this kind of learning systems or even AI assistance for coding that supports our learning, these type of data matters. So the future of learning and collaborating with AI is going to be much more diverse. It's not going to be just us typing in a question and getting like a wall of text. It will have, depending on the task and the domain and our level of knowledge and expertise and time and incentives, it's going to have so many more facets. So I'm going to leave you with this. And thank you for your time and attention. And hope you enjoy the rest of the conference. Thank you so much.